In the last session, we have studied Boolean algebra and the theorems associated with Boolean algebra. In all these theorems, some logical operations are involved, and on analyzing these, we can see that the only logical operations involved are and, or, and not logical operations. So, these operations are better known as the basic logical operations. To perform any logical operations, we use an electronic circuit. These electronic circuits which perform the logic operations are known as logic gates. The electronic circuits which perform or satisfies the basic logic operations, that is the and, or, and not operations, are obviously called a basic logic gate. So a logic gate can be defined as an electronic circuit that is used to implement a Boolean logic. NOT gate, AND gate, and OR gate are the basic logic gates. Now let's think about the features of a basic logic gate or the features of any logic gate as such. A logic gate will have one, two, or maybe many inputs, but it will have only one out. So the number of input terminals may be one or more, but always the output terminal will be only one. The output of the logic gate depends upon two factors. One, the input values that are fed to the logic gate. What type of values are you are feeding into the logic gate? That is the first thing. And most importantly, the type of logic gate or the type of logic operation performed by the gate. This means two different logic gates may give different outputs for the same input. Now let's think about the construction of the logic gates. In the construction of a logic gate, the first thing to be noted is that a high level or a high voltage in an electronic circuit is represented by a 1 in the Boolean algebra, and the low level or a low voltage is represented by a 0 in the Boolean algebra. So this is the preliminary thing to be noted in the case of logic gate operations. Now let's analyze the construction of different logic gates. Let's start with the NOT gate. The NOT gate has only one input and only one output. And the logic operation performed by the logic gate NOT is called inversion operation or complementation operation. This means we get the complement of the input and the output, or we could write the logic as output equal to complement of input. In other words, when a high level signal is applied at the input, the output will be low. And when a low level signal is applied at the input, the output becomes high. We know that usually the high level is represented by 1 and low level by 0 in the Boolean operation. Now let's think about the logic symbol. Here is a logic symbol of a NOT gate, and the output is represented by Y here. Y equal to A bar or A complement. Whatever value you feed in as the input, you will get the complement of that value as the output. That is, when you give a 1 here at the input, you will get a 0 at the output. When you give a 0 at the input, you are going to get a 1 at the output. So that is the logic symbol of a NOT gate. Then comes the truth table. What is a truth table? A truth table is a table of values showing the possible inputs and the corresponding outputs of a logic. The truth table of a NOT gate is this. You can imagine only two inputs, 0 or 1. And when the input is 0, the output will be 1. When the input is 1, the output will be 0. Now to the most important aspect of the logic gate. How do you implement this NOT logic gate in a circuit? For that purpose, we need an actual circuit. And this is the circuit. We have two figures here. In the first figure, a 1 is fed at the input. This terminal is the input terminal where we have given a 1, which means this is at a high voltage. A high voltage at the base of this transistor will make this transistor to switch on. Or in other words, the transistor is conducting. As a result, the collector voltage will make a current flow through the collector and the current will flow back to the earth at the emitter, which means the current flows through the transistor and will enter the earth, and no current will flow through the diode which is connected to the collector, because current always chooses the less resistive path. Here the less resistive path is through the transistor. So there is no glow of the LED at the output, which means you don't have an output or your output is 0. On the other hand, if the input is 0 here at the input side, the transistor is not biased properly, or the transistor is not switched on, which means the collector current cannot pass through the transistor, or the current cannot flow through the transistor, which means current has to go through other paths. And the only path available for the current is then through the LED. When current passes through LED, it glows, which means the output is now high, or the output is 1, which means when you give a 0 input, you get a 1 at the output. This is how the circuit works. Now let's move on to the next gate, which is the AND gate. About the input and output terminals, an AND gate can have two inputs or more than two inputs, but will have only one output. The logic operation of an AND gate is logical multiplication, and the output is high when all the inputs are high. Only when all the inputs are high, the output will become high. If any one of the input is low, then the output will be low. So this is the logic behind AND gate. Now let's see the symbol of AND gate. This is the symbol, and the AND operation is represented by a dot. What we read is Y equal to A and B. These are the inputs A and B, and this is the output Y equal to A and B. And the truth table is A and B are the inputs and Y is the output. This truth table pertains to a 2-input AND gate. You can have more inputs. Suppose you have another input C, then the output will be Y equal to A and B and C. For the 2-input AND gate, the possible inputs are 0, 0. The output will be 0. Then it can be 0, 1. The output is 0. It can be 1, 0, and the output is 0. When the inputs are 1 and 1, then the output will become 1, which means when the inputs are high at both terminals, the output becomes high. Now let's see how we realize this AND gate in an electronic circuit. And this is a circuit for the realization of an AND gate. So we have two diodes here, which are connected to the A terminal and B terminal. A positive voltage is connected at the P sides of both diodes, and the output is also taken from the common point of the anodes, and the output is given to LED. When 0 and 0 comes here, when A is 0 and B is 0, which means both A and B are at low values, or when A and B are connected to ground. 0 at A or B means the terminal is connected to ground. Then what happens? The voltage here creates a current which will go through the diode and will go to it will not go through the LED, and the LED will not glow. This is the case when A is 0 or B is 0 or both A and B are 0. When both A and B are 1, which means when A is connected to a high voltage and B is also connected to a high voltage, then the current cannot go to A or B. The current will always flow from a high potential to a low potential. But at this point, A is high, also B high. So current will search for other paths, and the other path is through the LED, because LED cathode is connected to ground, so it can flow to ground through the LED, and the LED glows, which means when A is 1 and B is 1, the output Y is 1. This is the operation of an AND gate. Now let's think about the last basic gate, which is the OR gate. The input and output terminals are just like AND gate. You can have two or more inputs and only one output. The logic operation is called logical addition. It's written multiplication there. It's not multiplication, but it is logical addition. And the logic is output is high when any one of the input is high. When A is high or B is high, or when A and B are high, the output is high. The output is low only when all the inputs are low. That is the logic behind OR gate. Let's see the symbol of OR gate. This is the symbol. The output is written as Y equal to A or B. The plus sign here, the addition symbol here, is spelled as A or B. Then the truth table is A and B both 0. The output will be 0. 0, 1. Output is 1. 1, 0. Output is 1. 1, 1. Output is 1. Now the circuit realization or the circuit. This is a circuit. Here also we are making the OR gate using two diodes, where the inputs are connected to the anodes of the diodes, and the cathodes are shorted together and is connected to an LED, and the cathode of the LED is connected to ground. This operation is very simple. When A is 1 or A is at high potential, that will create a current which will go through the diode. At this point, the current can go only through the LED, and the LED will glow. When B is high, the same thing happens. Current goes through the LED and it glows. When A and B both are high, again current will go through the LED, and the LED will glow. When A and B both are 0, there is no potential to create a current, and the output will be 0, or the LED will not glow. That is how the OR gate works. In the next class, we will see about more gates other than these basic